Hello, today we're going to be multiplying and dividing rationals on page 56. So, example 1, we have 3/4 times 7/8. So, this is in a ratio form, it's rational. So, what we can do is we can multiply the numerators with the denominators when you're multiplying fractions. So, you multiply 3 times 7 is 21. And you multiply 4 times 8 is 32. What I could have done is broken those down into prime factors. So I could have 3 over 2 squared times 7 over 2 squared times 2. And cancel, but in this case there's nothing to cancel. So, because it's all in primes, 21 over 32 is the final answer. In example 2, you have 12 over 7 times 14 over 3. So I did the same thing. 12 is 4 times 3, which is 2 squared times 3 over 7. 14 is 2 times 7 over 3. Watch this. Boom, 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 boom. And I have 2 squared times 2, which is 4 times 2, which is 8. And that's the answer. In example 3, I have 3/4 times 18/7. Break it down into prime factoring. 3 over 2 squared. 18 is 9 times 2, so 3 squared times 2 over 7. What can I break down? All I can break down is I have 2 to the 1 and 2 squared. So when you have a 2 to the 1 and 2 squared, you just subtract the exponents and you put the base number wherever the highest exponent was. So 2 minus 1 is 1. So 2 to the 1 and 2 squared just becomes 2 to the 1 down here. So then I have 3 times 3 squared, so 9 times 3 is 27 over 14, and then I can change that into a mixed number. I'm not going to do that right now. 12 over 35 times 42 over 27. 12, I broke that down into 4 times 3, which is 2 squared times 3. 35 is 7 times 5. 42 is 7 times 6, so 7 times 2 times 3. 27 is 9 times 3, so 3 squared times 3. Now let's see what I can break down here. I have a 3 squared, and I have 2 3's up here. So that's like saying 3 squared, so I can break those down. I can break this 7. Anything else? I don't think so. So what do I have left? 2 squared times 2, which is 2 cubed, over 5 times 3. Which is 15, so you get 8/15 as your answer. You shouldn't have to reduce if you do it this way. Okay, so now we have division. What do you do when you have 4/5 divided by 9/10? You have to take the reciprocal. Another name for the reciprocal is the multiplicative inverse. Okay, so the multiplicative inverse. Oops, forgot the E. Okay, so you have a division. 2 fractions, you have to take the reciprocal, which means flip it. So you always flip the second fraction. 4/5 times 10 over 9. Okay, so let's break that down into prime factorization. 2 squared over 5 times 2 over 3 squared. Okay, the only thing that I can see that I can cancel the 5s, so then I get 2 to the 3rd over 3 squared, which is 8/9. Okay, here's a 5. What's the reciprocal of 5? It's just 1/5. So 5/7. Take the reciprocal times 1/5. This is already broken into primes. My answer there is 1/7. 2/3 divided by 8/7 equals 2/3 times 7/8. That's going to be 2/3 times 7 over 2 cubed if you take the primes. Then look, I have 2 to the 1st and 2 cubed. 3 minus 1 is 2, so that's going to be 1, and that's going to be 2 squared, because that's the higher number, so it goes down to where the higher number is. So then I get 7 over 3 times 2 squared is 7 over 3 times 4, which is 7 over 12. This is a division symbol. 12 over 19 divided by negative 5/38. Now you have to go ahead and use what you know about multiplying and dividing negatives. This is going to be times the reciprocal, so it's going to be times 38 over 5. 38 over 5. Let's see, 12 is 2 squared times 3, because it's 4 times 3. 19 is like that. This is 38 is just 19 times 2 and 5. Okay, well at least my 19s cancel. That's cool. All right, so what do I get? 2 cubed times 3 over 5, which is 8 times 3 is 24 over 5. And then again, you can break that down into a mixed number. Mixed number, you know what that is, right? That would be 4 and 4/5. Okay, now we have decimals. 4.28 times 5.31. So you actually have to set it up. 4.28 times 5.31. You have to do out the multiplication, just like you normally would. 40, carry the 4, 10, 11, 12, 13, 14, 21. Okay, add that up. 12, 4, 5, 6, 7, 2, 2. And then you count over. How many count over do you have to get to the decimal? Ready? You go 1, 2, 3, 4. So you start here and you go 1, 2, 3, 4 and put the decimal point there. If the decimal was there, then we'd count over 1, 2, 3. If the decimal was there, we'd count over 1, 2, 3, 4, 5. Wherever the decimals are, you count over that many, and then put them in. The last thing is 1.26 divided by 0.3. That's just like writing 1.26 over 0.3. So we have to divide the bottom number into the top, number. So 0.3 into 1.26. Anytime you have a decimal in a division problem, you have to move it over 1. But if I do that, I have to move that over 1. So now I get 3 into 12 is 4, 3 into 6 is 2, and the answer is 4.2. If this was negative, you'd have to follow the negative rules. Remember, a negative divided by a negative is a positive. A negative times a negative is a positive. And then if you have one negative and one positive and you're multiplying or dividing, it will always be negative. All right, so your homework or your home joy is page 59, 1 through 26. Oh, Allison, I saw that. All right, I will talk to you later. Have a good day. Bye. Go Ram.